Welcome to Auto 155, Electricity and Electronics 1. My name is Tony DeBlasi, and in this lecture I will be covering Charging System Diagnosis and Service. This is a two-part lecture based on Chapter 55 from the Automotive Technology Principles, Diagnosis and Service 6th edition. For additional information on this topic, please read this chapter and refer to the PowerPoint found in the course content folder. Please note that there are both audio and visual lecture attendance codes scattered throughout this lecture. Please write these codes down as you see and hear them. At the completion of this lecture, you will be required to go to the assignment folder and take the online lecture attendance quiz in order to get credit for attending this lecture. The following is an overview of the objectives covered in this lecture. I will discuss the various methods to test the charging system. I will discuss how to inspect and adjust drive belts. I will discuss the alternator output test and minimum required output. And I will explain how to remove, disassemble, reassemble, and install an alternator and test its component parts. The information found in this chapter will help you prepare for the ASE Electrical Electronics Systems A6 Certification Test Content Area C. So when you are going to be testing your charging system, and you'll hear me refer to this later on, whenever you're testing your charging system, you want to make sure that your battery's state of charge is a minimum of 75%. So that, in other words, that's 12.4 volts. And you'll notice that that's kind of a running theme, especially when we discussed earlier in the semester when we were talking about starting or cranking system testing. We wanted to have the battery's state of charge at least at 75%. So the same holds true for charging systems. So when we are doing a voltage test, a charging system voltage test, we want to set our meter to DC volts. We will be doing a test later that requires AC, but for right now we're looking at its ability to make volts for the system. So we want to set our meter to read DC volts first. You're going to connect your meter leads directly to the battery, because when you have your charging system running, the battery is part of that system. And sometimes your alternator is very difficult to get to with the engine running, so this is a great test to do right at the battery terminals. You're going to be running the engine or operating the engine at a maximum of 2,000 RPM. We don't want to go any higher than that. Normally when a vehicle first starts, 1,500 is very, very common, but the maximum we're going to be putting is 2,000 RPM. The specifications we're looking for are, I've always said between 13 and 15. I know the fourth bullet here says 13.5 to 15 volts, but once again, it could be a little under 13 or even a little over 15, but that's generally what we're going to be looking for as far as our range goes. In this day and age, the other piece of this is we can also use a scan tool to test the charging system. Now, I know we haven't spent a lot of time going over the basics of a scan tool. That's more or less electrical too. But many vehicles out there are using computer-controlled charging systems, and especially in this day and age. So that's a really cool thing that you can actually use a scan tool now to do a lot of your testing. We can monitor charging voltage, and we can also look at the field circuit and we can see its on and off duty cycle with a scan tool. So here's an example of a meter that is set to read DC voltage, and it's connected to the positive and negative terminals of the battery. And you can see that the meter's voltage reads 14.45 or 14.5. And that's a very common voltage that you'll see with the engine running. In this slide, you're looking at a scan tool. So a basic scan tool, once again, can be used to tell different aspects or parameters of a charging system. In this tech tip, you can see that they're describing the use of a test light to check for a defective wire somewhere between the B terminal of the alternator and back to the battery again. And you could imagine if it's not providing the correct voltage, naturally one would assume that the alternator is bad. So there have been techs in the past that have just simply replaced an alternator because there was lower than expected charging system voltage. But they never checked that the wiring between the B nut or the B terminal and the fuse box was good. So one quick test that you can use is you can attach one lead from your test light to the battery's negative and the probe tip of the test light to the B terminal of the actual alternator to verify if there's light. This is a quick test, very simple, and you cannot underestimate how important it is to check for that. You can also use a multimeter as well. You're basically looking for voltage at that B terminal. Chapter 55, lecture code question number 2. Please write this down. 879371. Once again, that is 879371. Please write this down. As we continue, we need to discuss drive belt inspection and adjustment. So the first thing we're going to do is a visual inspection of the drive belt. So what I'm looking for is I'm looking for cracks. That's a traditional thing that we want to look at. Or if there are cracks or slices or physical damage in the belt, then obviously that's something that needs to be taken into consideration for replacement. The general rule is that if you see any more than 3 cracks in any one rib that appears in a 3-inch span of belt, then that would be due for replacement. We'll get into this a little bit more in a moment. The other thing you need to consider is tension. You need the correct amount of tension. You can't be too loose, you can't be too tight or too taut. We need, once again, that Goldilocks zone, that just right zone. We want to have the right amount of tension. So you can use a tension gauge. You can use marks on the actual tensioner pulley assembly as well. You can use your torque wrench readings. The best measurement that I've used, and it's quick and you have it already with you, is the deflection measurement. We'll get into that. It's a pretty quick test to tell. It's deflection. There's also a twist move we can do. And then we'll discuss the overrunning clutch. In the last chapter, we discussed OAPs and OADs as far as the pulleys go, so overrunning alternator pulley and overrunning alternator damper. We'll show an example on how to deal with those as well. Here's an example of a neoprene traditional serpentine belt or accessory drive belt, and you can see there's cracks in it and chunks taken out of it. This is pretty easy to see that this belt is damaged and needs to be replaced. However, the newer belts are difficult to tell when they're showing wear, and this is because they don't crack like these older neoprene belts, and I'll show an example here in a side-to-side in a moment. The newer belts are EPDM, and I'll try to say this right, but it's ethylene propylene diene monomer. They don't crack. They may show like a glazing, but they don't crack, so it's difficult to just look at it and say it needs to be replaced. Chapter 55, lecture code question number 3. Please write this down. 22986. Once again, that is 22986. Please write this down. One way to tell if an EPDM belt needs to be replaced is to use some type of gauge. And this gauge here in this example is a belt wear gauge. It has little grooves cut into it that drop into the actual grooves and match up with the grooves on the accessory drive belt. The gauge should fit tightly as its grooves should mate perfectly with the grooves in the belt. If it moves side to side, then the belt is worn and should be replaced. Now the example on the left-hand side of this slide shows the EPDM belt, and it shows a different type of gauge. In this example, you can see how the gauge doesn't sit all the way down into the actual V of the belt, and that means that it's good. In this example on the right, you can see how the gauge actually settles into the belt. That means that it's worn. So that's one way to tell. And once again, on the right-hand side, this is our neoprene belt with the cracks. Just to refresh, we don't want to see any more than 3 cracks in any one rib that appears in a 3-inch span or section of belt. As stated previously, belt deflection is important. We want to have the ideal tension on our belt. This can be done many different ways, but the easiest way to do this is with your own fingertips. If you find a section of belt between 2 pulleys that's around about a foot, if you can find it, that is, what I'll do is I'll place my thumb in the very center and I'll depress it. And what we're looking for is about a 1/2 inch of deflection at its widest span, which would be, like I said, a minimum of 1 foot. Greater is even better if you have more than a foot. The other thing you can do is twist the belt. So if it's a wider belt with many ribs across, if you were to grab the belt and give it a twist, you should be able to get up to about a 90-degree deflection or a 90-degree twist at its widest span. Any more than that, it's too loose. Any less than that, it might be too taut. This chart actually shows a range of the pounds of tension that can be applied based on the number of ribs for the specific belt. So, for example, if I had a belt with 6 ribs across, I should be able to put a tension of between 90 and 125 pounds at that widest span. And there are certain gauges that can test for that. If I'm using a V belt, well, if it's a 5/16" V-belt across the top, I should be able to apply between 60 and 85 pounds at the widest span. This slide shows a photo of a tensioner pulley assembly, and if you look inside the circle, there are marks. Now those marks vary based on where they are as far as tension goes. You will need to check service information for that. This photo is a picture of an overrunning alternator damper, as we covered in the last chapter. It's a bit longer because it has a spring inside. It contains a damper spring or dampener spring inside, as well as a one-way clutch. Now, in order to remove an OAP or an OAD, you'll need a specialized tool to do that, and this is a photo of that here. A good alternator should produce very little to almost no AC voltage at all, and that's due in large part to the rectifier bridge, where the diodes will actually filter out any AC voltage, as we've discussed in prior lectures. The test we're going to use to verify if there is an acceptable amount of AC coming out of the alternator, like I said, which should be very little, is referred to as an AC ripple test. So the AC ripple voltage has to stay under 400 millivolts. Some testing equipment will trigger an issue if it goes greater than 200 millivolts. You can do a quick AC ripple voltage test with your meter. First, you set your meter to read AC volts, and you want to dial it down to the millivolt scale. You want to start the engine, and you do not want to rev the RPMs any higher than 2,000. You're going to connect the multimeter right to the battery terminals, and you should turn on the headlights to load it up a little bit. And once again, we want to look at the meter, and we want to see something less than 400 millivolts. If you can get the meter directly on the alternator like it is here, so you notice that the red lead is right on the B terminal or the BAT terminal, while the negative lead or the ground lead or the COM lead is right on the actual chassis of the alternator itself, then you're probably going to get an even more accurate reading because you're not factoring in the resistance of the wires. If you have an AC ripple that's above 500 millivolts or 0.5 volts, you could potentially have a problem in the diodes themselves. It should be noted that very low battery voltage can trigger an excessive ripple result. This is important to know. So if I have a battery that's dead or discharged and I'm doing this test and I have a high AC ripple, it's probably because I have a battery with low voltage. And remember, at the beginning of this module or at the beginning of this lecture, I said all of the tests that we want to do when we're testing a charging system, we want to have 75% state of charge or better, or 12.4 volts or higher. So if you notice that you have a high AC ripple and you know that your battery is low in voltage, it would be best to charge that battery up, then do this test again for more accuracy. If you still have a high AC ripple after you've verified that you have a good battery, then you probably do have a problem with the alternator itself or the rectifier bridge specifically within the alternator. One cool little trick that you can use to get both a voltage test and an AC ripple voltage test is to make or to fashion a lighter plug. Take like a lighter plug, and then from that wire where it inserts into, I say lighter plug, it could be I think they're called power points now, but the wire that comes off of that, if you were to cut a wire and then splice it off, you could attach your multimeter to those exposed ends. And here's an actual photo of what that looks like. So you could make one of these yourself. So this end here would go into the plug, obviously, and then your multimeter would attach to these 2 points. And you could sit behind the wheel and look at your voltage measurements, and you could do both the voltage test, DC, and the AC ripple test. We talked about AC ripple voltage, but you can also test for AC ripple current. To do this, you'll need an amp clamp. Several times this semester, I've recommended a small mini amp clamp that is designed just for that purpose, for amperage, an inductive clamp. These work out really well for this test. What you want to do is you want to start the engine and turn on the lights to apply a load. Place the mini amp clamp around either of the positive or the negative cables. It doesn't matter which one's coming from the battery. You want to switch the meter to read AC amperes, and then you want to record the reading. What we're looking for is less than 10% of the specified alternator rating. So if I have a 100 amp alternator putting out up to around 100 amps, I don't want to see any more than 10 amps. In fact, I want to see less than that. Here's an example of that mini amp clamp connected to the wire that comes off of the B-nut. It is strongly recommended that you keep this little mini amp clamp away from the actual physical case of the alternator itself, because it does have a magnetic field inside, and that magnetic field can throw off the actual inductive clamp itself. Based on the number here, it shows that my alternator is outputting 105 amps DC. If I were to switch the dial to the AC setting, I shouldn't see any more than 10.5. That would be 10%. In fact, like I said, I want to see less than that. This concludes the Part 1 lecture for Chapter 55. Charging System Diagnosis and Service. For additional information on this topic, please read this chapter and refer to the PowerPoint found in the Course Content folder. Now that you have completed this lecture and you have written down the online lecture attendance codes, please go to the assignment folder and take the online lecture attendance quiz in order to get credit for attending this lecture.